This is Laboratory 4. This is for my virtual students and students that missed this Thursday, the 4th. So we're going to start with opening up your dedicated lab folders, and you're going to write Lab 4 in the top left-hand corner. Now, everything I show you here, you do not write down for your lab. The reason I told you this is because this is what I need to see when you send me the pictures and you upload them to your participation lab on Thursday, the 4th. You're going to upload your picture of your actual page 40 and 41 and 42 when you do the procedures. We're not going to weigh out the salt and the sugar. We're not going to mix it with water. We're just going to focus on the math, on the molecular mass or the atomic mass, and we're going to talk about what moles are, okay? So let's get started. This is just an explanation of the math for this section. So a water molecule is H2O, right? That 2 is called a subscript. In chemical formulas, it tells how many atoms of that element are present in one molecule. This is a whole molecule. This is an element, and this is an element. A molecule is the combination of elements. Okay, so we're going to start with water, H2O. You're going to refer to page 51. Let me see. You're going to go to page 51 where your periodic table is, and you're going to open it up and you're going to look at that bottom number right above the name. That bottom number is called the atomic mass. The atomic mass is how many grams that element weighs. In hydrogen, it's 1.00794, but we only go to the second place past the decimal on the right. So we're going to just say that hydrogen weighs 1 gram. So hydrogen weighs 1 gram. Oxygen, if you go to oxygen, it says 15.99. We're going to round that up to 16. So oxygen is 16 grams. And now we're going to do the math to figure out how much they weigh. Now, before we get started, 1 gram of hydrogen is 1 mole of hydrogen. 16 grams of oxygen is 1 mole of oxygen. You following me? So, because there's 2 hydrogen, we're going to do 1 times 2 equals 2. Because there's no subscript under the O, that means that there's only 1. So we're going to go 16 times 1 is 16. And then we're going to add them together. And we're going to have 18 grams or 1 mole of H2O. Okay, that's how much a mole of H2O weighs, is 18 grams. So last week when we did the 9 milliliters in the graduated cylinder of water, that was half a mole, to kind of give you a hands-on. So now we're going to look at sugar, okay? And that's going to kind of give you the answer to one of your questions in your lab. But sugar is 12 carbon, 22 hydrogen, and 11 oxygen. Well, let's see how much carbon weighs. So carbon, if you go over here, it weighs 12 grams. So carbon weighs 12 grams. We already know hydrogen weighs 1 and oxygen weighs 16. So how do you figure out what a mole of sugar weighs? Because this is the molecule of a sugar molecule. So how much does this weigh? It's going to be a lot more than water, I'll tell you that. So 1 mole of sugar, you do 12 grams times 12 carbon, which gives you 144 grams. So this is 144 grams of carbon. This is 1 gram times 22, which gives you 22 grams. So it's 22 grams of hydrogen. And this oxygen is 16 grams times 11, which is 176 grams. Okay? So all together, added up, they're 342 grams or 1 mole of sugar. 1 mole of sugar weighs 342 grams. That's ridiculous. That's a lot of sugar. Okay, now we're going to go to salt. We're going to do salt real quick. So if you look up what sodium weighs, you'll see that it weighs 23 grams. Okay? It weighs 23 grams. And chlorine over here weighs 35.45. Well, we always round up to that second place, so that 4-5 rounds up to 5. So it's 58.5 grams. So that's how, or 35.5 grams is how much chlorine weighs. Because we don't have any subscript in here, each one of these is 1, so we don't have to do the multiplication. We just do 23 plus 35.5, which gives you 58.5 grams of salt. And 58.5 grams of salt is 1 mole. So when we use 1 gram of salt, we weren't even using a mole of salt. Okay? So now we're going to go over to page 439. And we're going to talk about this math right here. Okay, so 1 mole of NaCl, it says this means that if you want to make 1 mole solution of salt, you would add that 58 grams of salt to a liter of water. And this is how it's written. Now you have to be specific. It's so much easier to skip over everything and just write it correctly. But I want to see the math written out. So when it asks you to do the math, you're going to write it out like this. So 1 mole looks like, this is the definition of 1 mole liter of salt water. Okay? And this equals out to be like this. So we're going to do the mole to gram conversion factor. 1 mole of NaCl is 58 grams over 1 mole. We're going to cancel the units in the numerator and denominator, which is going to leave us with 58.5 grams over 1 liter of H2O, and this is my answer. And if we're going to do the next step, we're going to multiply that by half, which will give us 29.25 over 0.5 liters of NaC of water. Okay? So this is how you do the math. You're left with this once you cancel out this. And that's what the math looks like. You're not going to have to do this in your lab, but it's really good to know this and practice this. So go ahead and write it out. When you walk through your lessons and it has explanations of math equations, work it out as you read. You're not just reading something anymore, but you're learning how to work out math step by step. So follow that advice that I'm giving you, okay? So now we're going to our procedures in our laboratory 4, and this is where you write lab 4 in the top left hand corner, and you're going to work out 1AB, 2ABC, D, 3A and B, and you're going to number and letter them the way that it is listed in your laboratory notes. Okay, so when you open your book, you're going to write number 1 moles of table salt, and you're going to measure out. You know, you're not going to physically measure these out. You're just going to write this down. Think about it. You're measuring out 10 grams of salt. How many moles of NaCl do you have, and how do you do the math? Well, these are some of the similar numbers, but we're not talking about 15 grams. We're only talking about 10. So you're going to do 10 grams divided by 58.8, and you're going to write that out. You don't have to write all this explanation out. Just write the math out. 10 divided by 58.8, and remember to circle your answer. Circle your answer so I'll know that that's the answer that you've come up with. Now, the number 2, moles of sugar, you don't have to, you just write these numbers and grams of sugar out. So A, you would write 10 grams of sugar. B, you would write How many moles of sugar do you have in 10 grams? You're going to do the same math with this. So if you have 10 grams, you're going to do 10 over whatever that number is, and we figured that number out to be 342 grams, which I shouldn't have given you the answer, but I did. So you're going to do 10 over 342 grams, and then you're going to answer this question. Are they the same number of moles? If not, which has more moles? How is it possible for 10 grams of sugar and 10 grams of salt to be different number of moles? And so answer that question. Now, answer D. Then you're going to do 3, baking soda, weigh it. And I did not do the math for baking soda for you. You have to figure that out. This is the molecule for baking soda. So you're going to do the math for the baking soda. You're going to circle the answer. And you're going to answer these questions. And then you're going to take a picture of that and send it to me on the laboratory participation on Thursday. And if any of you have any questions, let me know. If you need more help, just email me and shoot me a text and say, I emailed you a question, I need your help, and I will get online and I will figure out what you need. So it's been great teaching you this. If you have any questions, I've already said that. Talk to you later. Bye.